Let's go over some quick examples in section 1.3. Question number 1. Let's take the square root of negative 27. When I see these kind of questions, I always pull out the I first. Take out the I, then leave the radical alone until you simplify it. Now, since we're looking at the square root of 27, we want to look for groups of 2. This is 3 times 3 times 3. I can pull out a pair of 3's from this. So let's pull out a pair of 3's and bring that to the front. We have 3i root 3. And that's the simplest I can make this example. In example 2, we have the same situation. This time I have 2 radicals. Pull out the I from both of them first before you begin the problem. So since we took out the square root of negative 1, that's going to give us the I in the front. Now I times I is I squared. And then we have the square root of 8 times the square root of 2. That's the square root of 16. I can simplify the square root of 16 as 4. And then we can simplify the I squared. We know I squared, that's just negative 1. That's by definition. Please don't forget that. I squared is equal to negative 1. By definition, don't forget it. So this is equal to negative 4. For example 3, I could again pull out the I from the top and leave that as an 84. On the bottom, we'll leave that alone for now. We can use the quotient rule. What does the quotient rule say? It says I can take a radical as a fraction and split it into 2 radicals. That's what the quotient rule says I can do. But remember, it can go in either direction. I could say that if we have 2 separate square roots, I can combine it into one bigger square root. So let's do that. Let's say that's 84 over 12. 84 over 12, that is equivalent to 7. So we can simplify this as I root 7. In example 4, there's again a lot of these radicals with negatives inside. Pull out the I first. Each time bringing that square root of negative 1 to the front. Every time I have a square root of a negative, pull out the I and make the radicand positive. Now we have a situation where we have I times I, that's I squared. And then I can combine the square root of 6 times the square root of 3, that's the square root of 18. 3 times 6 is 18. The I squared can be simplified as negative 1. And the square root of 18 over the square root of 2, I can write that as 18 over 2, again using our quotient rule. So this negative 1 times this radical is going to give us a negative. But what's the square root of 9? Well, that's equivalent to 3. So my solution is equal to negative 3. In example 5, again, there's a radical with a negative inside, so pull out that I to the front and make it a positive 108. Don't feel tempted to reduce the 6 into 3. A lot of people do that. You don't want to simplify it that way. 108, let's break it down with the factor tree. That's 2 times 54. I could break that again. That's 2 times 27. That's 3 times 9, and that's 3 times 3. So let's rewrite this as a product of these numbers. So let's do 2, 2, 3, 3, 3. Again, if you're not sure, why don't you multiply 2 times 2 times 3 times 3 times 3, and it better give us 108. And you can check that for yourself, make sure it's right. Looking for groups of 2 here. So I get 6 minus, this 2 times 2 is going to go to the front. So I have 6i over 3. Oh, I forgot a radical here. This should be the square root of 3. because there's still a 3 left. Now I can actually reduce now. The 6, and the 3. That's okay to do because they're on the outside of the radical. So we have 2 minus 2i root 3. I could put that over a 1, but that's not what we need to do. We need to make it simplified to leave out the 1. We have 2 minus 2i root 3. That's it. We can't simplify it further than that. In example 6, it says to add these two. Don't feel tempted to multiply it out with foiling. There is an addition sign in between. What I need us to do is remove those parentheses. We don't need them. Take them out. Then collect like terms. 3 plus 4, that's 7. We have 5i minus 4i, that's 1i. And of course, we don't have to write it as 1i. I could just have put 7 plus I. That looks better. And that is a good solution. In example 7, I want to distribute first the negative. That's the most common mistake I see. People forget to distribute the negative. I'm going to distribute it here. That becomes a plus 2, and that becomes a plus I. Now I can simplify. 6 plus 2, that's 8. 9i plus I, that's 10i. And we can't add the 8 and the 10i. They're not like terms, so we stop here. 8 plus 10i is a good answer. In example 8, now this is a multiplication problem. Notice there's nothing between those parentheses, so this is a foiling problem. We'll multiply the first terms together. 4 times 5 is 20. Is equivalent to 20. 4 times I is 4i. Negative 4i times 5 is negative 20i. Negative 4i times I is negative 4i squared. Now let's simplify. I have 20. Well, 4i minus 20i, that's negative 16i. And recall that I squared, again, is equal to negative 1. So I can multiply negative 1 times negative 4. That gives me a positive 4. So we can now collect the 20 and the 4 together. Makes us 24 minus 16i. And that completes example 8. In example 9, again, this is a multiplication problem. I want to write this twice. That's what it means to be raised to the power of 2. We're multiplying it by that base twice. We'll be forced to FOIL. 8 times 8 is 64. 8 times negative 3i is negative 24i. 3i times 8 is again a negative 24i. And then negative 3i times negative 3i is plus 9i squared. Now let's simplify. We have 64. These together make negative 48i. And we all know what 9i squared is. I squared equals negative 1. So 9i squared is negative 9. 64 minus 9 is 55 minus 48i. And that's the simplest we can make this problem. We are done with example 9. This is the good stuff. Example 10, I need to use the conjugate of the denominator. Since this is a plus, use minus. So we have 4 minus 3i on the bottom and use the same thing on the top. Multiply the top and bottom by the conjugate. I have to FOIL the top. I can't use any shortcuts for the top. 7i times 4 is 28i. 7i times negative 3 is negative 21i squared. That's just the top. Don't forget you have a bottom. So we're going to have to do the bottom. This is the difference of squares. Recall a plus b times a minus b is a squared minus b squared. So I can say this is 4 squared minus 3i squared. This is the difference of squares. So we'll have to simplify the top and bottom. We have 4. I can't add anything with that yet, so we'll leave that alone. I have negative 3i and 28i. That's 25i altogether. And then this becomes, again, I squared equals negative 1. This becomes a plus 21. For the bottom, I have 16, and 3i squared is 9i squared. Let's simplify the top. 4 plus 21, that's 25, plus 25i. And then for the bottom, I know this is actually a plus 9. This is a plus 9 down here because I squared is negative 1. So 9 plus 16 is 25 on the bottom. Hey, we can simplify each and every one of these. So we have 1 plus I is our solution for example 10. In example 11, there is a trick. Remember the trick? You got to divide by 4. Divide by 4. So let's take the 10 and we'll divide it by 4. 4 goes into there twice. I get 8, subtract, and you get a 2. So 10 divided by 4 is 2 remainder 2. I only care about the remainder. I to the 10 is equal to I squared, our new remainder. What's I squared? We know that's negative 1. So this simplifies to negative 1. Example 12 is the same way. Let's take 44 divided by 4. I get 11 remainder 0. I only care about the remainder. Remember, the pattern repeats. I to the 0 equals 1. I to the 1 equals I squared equals negative 1. I cubed equals negative I. That's the only 4 you really need to know, because the remainder after you divide by 4 is going to be 0, 1, 2, or 3. So this is equivalent to I to the 0, but I know that's equal to 1. So these questions aren't too bad. You just got to remember the trick, divide by 4.